Hello, welcome back. So we're going to dive right into our next lesson, which is Level E, Section 2. This is about whole numbers and operations. So the things we're going to cover in here are going to be things like adding and subtracting whole numbers, multiplying, dividing. We're going to talk about some number properties, number lines, some shapes and patterns type thing. And when we're done, you should be able to go through the Essential Ed lesson for Level E Section 2 and complete it without any difficulty. So here we go. First topic we're going to talk about in this video is going to be addition and subtraction for whole numbers. So when you have two numbers that you add together, there's of course the easiest way, which would be to just plug it into a calculator. The actual way is to do it on paper. So the first topic is going to be addition and subtraction for whole numbers. Now, what we're going to do is we're going to set these numbers up in a vertical fashion, like you could see on these first examples I have set up here. And basically, all you really do is you just go from right to left, and you add vertically. And if anything carries over, you put it into the next column. So let me actually zoom this paper in a little so we can see a little better. Yep. So if I'm working on my first example here, I'm going to take 2 and 2 and add them together, and that gives me 4. And nothing carries over for this problem, for that operation of 2 plus 2, so there's nothing else for us to move over. We just move to the next place value. So now we add the tens. 8 and 0 adds together to make 8. Once again, nothing carries over, so now we just move on to the next column. That's the hundreds place. 7 and 6 added together makes 13. So there's going to be a 3 here, and then that 1 from the 13, the tens place of that result, you're going to carry over into the next column. And so you might be saying, well, wait, there isn't an extra column there because there's no more numbers. But that's okay because you're making that extra column because you have this 1 that carried over. So what you do is you add 1 and this imaginary 0 that's here and this imaginary 0 that's here, and you put the result down at the bottom. So when you add 782 and 602 together, you end up with 1,384 as your result. Now, just so you are aware, anytime that you do an addition problem and you come up with a result for that addition problem, the answer is called a sum. So I'm going to change colors here. We're going to go ahead and just circle this, and this is called the sum, okay? And if you're doing a subtraction problem, the result is called a difference. We'll get to that in a second, but the results of all these different operations have different names, so you just want to be on the lookout for those, so that if a question says what's the sum of whatever, you'll know that you're supposed to add the numbers together in order to get that result. Okay, so next column, we're going to add 6 and 9. When you add those together, that makes 15. So there's a 5 here, and you carry the 1. So now I add 6, 2, and 1. So 6 and 2 is 8, and another 1 is 9. And nothing carries over. And then 5 and 9 combined together makes 14. So that's going to be a 4 here and a 1 in the thousands place. There's nothing in the thousands place here and nothing in the thousands place here. So you just add 1, 0, and 0, and you get a 1, okay? So I'm actually what I'm going to do is I want you to go ahead and I want you to pause the video, and I want you to work out, I'm going to asterisk them so you know what I'm talking about. I want you to work out this problem, and this problem, because those are all addition. I want you to pause the video and try those on your own, and then when you're ready, come back and unpause the video, and we'll go ahead and do them together. Okay, so when we look at the first example, we're going to add 5 and 1, that makes 6. And then next column, we have 4 and 4, that makes 8. And our last column is 6 and 6, which makes 12. And we have 1 that carries over. So we have 1, and plus 0 makes 1. So our result is 1,286. And then we move on to this next example. 9 and 3 is 13. Carry the 1 over, that's to the tens place. 6 and 3 and 1 is 10, so that's going to be Now that might be a new one actually, because we haven't seen that yet. But what happens is when you have 10, you put the number in the ones place here. Okay, so remember, if you have 10, this is the ones place, and this represents the tens place. Okay, so the ones place goes down here, and the tens place goes up to the next column. So 5, 1, and 1 makes 7, and that's it. When you add 534 and 169 together, you get 703. And the last problem I said to do in the pause was this next one. So this is 15, 1 carries over, that's 5, 6, 7, and then 2 and 1 makes 3, and that result will be 375. Okay, so our next little skill here is going to be subtraction. So that's when you have one quantity and you take away a quantity of that from that number. So if I had 100 apples and I eat 10 of them, I'm taking away 10 apples from that total of 100, and I end up getting 90 as my result. So that's an example of subtraction. What we want to do here is we want to do the same type of solving where we start at the right and we subtract down, and then we move on to the next column. So 9 minus 9 gives me 0. 6 minus 3 gives me 3. And then 7 minus 4 gives me 3. So 769 minus 439, it gives me a 330. Okay, so in our next example, we have 619 minus 374. And something we're going to notice here is that it's not going to be just as easy as the one we just did, because in the last example, all of the numbers we were subtracting were actually smaller than the ones above them. But in the next example, if you look at when we get to 1 minus 7, well, how do you do 1 minus 7? You get like a negative number if you do that. So that's not the right way to do this. We have to do an operation called borrowing in order to figure that out. So let's jump in. So 9 minus 4 gives me 5. And then when I get to the 1 minus 7, what I have to do is I actually have to go to the next column to the left and take 1 away from that top number and let my column here in the middle borrow that. So this is not a 6 anymore. It's going to be a 5 because we reduced that by 1. And then this is not a 1 anymore. It's going to be 11 because we took 1 away from this 6, and we had a 1 already there. So 11 minus 7 is going to give me a 4. And then I come to this column and I have only a 5 here now, not a 6. And 5 minus 3 gives me 2. So 619 minus 374 gives me 245. Go ahead and pause the video now, and I want you to work on this last problem for the subtraction. Okay, so what we have here is 6 minus 7. 6 is smaller than 7, so we need to change this 9 to an 8. And then this becomes a 16. Okay, so 16 minus 7 is 9. And then 8 minus 0 is 8, because if you take nothing away from it, it's itself. And then you have 4 minus 1, which is 3. So 496 minus 107 gives me 389. Okay, next skill is multiplying whole numbers. So anytime that you're multiplying, you are basically just taking some value and you are adding it to itself the amount of times that's in the second value. So if I look at my first example here, I have the number 7 multiplied by 6. So I take 7 and add it to itself 6 times. Now that's a really simplistic way of looking at it. What you really have to do is you need to try and line the stuff up into place value and then follow a similar operation that we were doing with the adding and subtracting. So 7 times 6, no tens values, no hundreds, this is all ones. So basically you just need to do 7 and do it 6 times. And so I know what my result is. I know that my result is going to be 42. And the reason I know that is because 7 and 7 is 14. Another 7 would give me 21. Another 7 would give me 28, 35, and then 42. And that is 6 times that I added 7 to itself. So if you kind of want to like mirror this back to a previous lesson, in the last lesson we actually talked about skip counting. And skip counting is when you start at a value and then you count that many places ahead. So 7, skip ahead 7 gives me 14, skip ahead 7 gives me 21, so on and so on. So if you want to think about it that way, you're skipping ahead 6 times to get to the next multiple of 7, if that makes sense. So 7 times 6 gives me a 42. 5 times 3, want to add 5 to itself 3 times. 5 and 5 is 10, and then another 5 gives me 15. 7 times 9. Now, you can sit there and you can do 7 and 7 and 7, all those 9 times up to it, but there is such a thing called a times table, and the 9 times table is actually like a pretty commonly used one. In fact, if I'm thinking back, I don't really know that I've ever referred back to any other times table. I've just kind of like done the math, but like my 9 times table I remember a lot. So if I roll my page over, you might want to put this in your 9 times table. You want to put this in your notes. We're going to make a 9 times table. So you take 9 times 1, 2, 3, 4, 5, 6, 7, 8, 9. And I mean, you can keep going from there too, but these are like the most common ones. So 9 times 1 gives me a 9, and then that's 18, 27, 36, 45, 54, 63, 72, 81. And if you notice a pattern here, in this 9 times table, the ones place is going down by 1. So 9, 8, 7, 6, 5, 4, 3, 2, 1. And the tens place is going up. So 0, 1, 2, 3, 4, 5, 6, 7, 8, and then it would keep going to 90, which is 9 and 0. So a pretty interesting pattern there. You might want to jot that one down in your notes just so you have it down. We're going to apply this information to solve this problem. So 7 times 9, 7 added to itself 9 times, gives me a 63. Whoa, we're writing that all over the place. That's interesting. Hold on. Okay, we are zoomed back in. Here we go. Okay, 63. Okay, we're going to move on to our next one, which is 8 times 6. I know the answer is going to be 48. There's a couple ways you can do this. So if you break it down, okay, if you do split the 6 in half, okay, so take the result of 8 times 3 and add it to the result of 8 times 3. Those are going to be equivalent expressions. You're just splitting this this multiplier in half. So 8 times 3 is 24. I don't know why I suddenly can't draw on here. Here we go. 24. And 8 times 3 is 24, and when you add these together, you get 48. Or you could count 8, 16, 24, 32, 40, and then 48. That's 6 times. That gives you 48. So two strategies you can follow there. Okay, so what I want you to do is pause this video, and I want you to attempt this next problem and see if you have any ideas about what you actually get when you do that calculation. Okay, so if I'm looking at this, what this is saying is that I need to add 5 to itself 12 times, okay, or I can add 12 to itself 5 times. They're interchangeable, and we'll talk about why that is later on. But an easy, quick way to do this is actually I'm gonna write it the other way because this is not the easiest way. 12 times 5. So take 5 times 2 first, okay, and that's going to give you 10. And then I also want you to take 5 times this tens place, and that would be 5 times 10, okay, and that gives you 50. I want you to add this result together, and that's going to give you 60, okay? The actual answer is 60, okay? And then other problems may have like double digits in the bottom, and that's fine. You can still do the same process, and I'm going to show you how. So the first thing I'm going to do is start with this 4. I'm going to zoom this problem in a little. Start with this 4, multiply up to the 1, so that's going to give you a 4, and then multiply over to this tens place, and that's going to give you 40. I wrote it on the wrong line, sorry. 40. And then I want you to take this 1 and multiply it by, this 1 represents 10 because it's in the tens place, right? So I want you to do 10 times 1, which is going to give you 10. And then I want you to do 10 times 10, which is 100. And then you add all this together and you get 154. And that's your result, okay? We're going to do the same thing again with the next problem. Now, if you notice some similarities here, this is 11 times 14, and this one is 10 times 14. So since the 14s are the same, and the only difference is the number you multiplied by, you, instead of having 11 14s, now you only have 10 of them. And so you can just reduce this result by 14 and you get 140. But let's show you, instead of looking at it from a pattern perspective, let's show you how you would just do this multiplication. So you would do 4 times 0, which gives me 0, and then 4 in the ones place times 1 in the tens place is 4 times 10. And 4 times 10 is going to give you 40. The next thing is going to be 1 times 0 in the ones place. Well, this is actually 1 in the tens place, so this is 10. 10 times 0 is 0. And then 10 times 10 is 100. If you add all these results together, I don't know why my screen's jumping around like that, sorry. If you add all these results together, you get 0 in this place, 4 and 0 in this place is 4, and then 100, and your answer is 140. Okay, so pause the video and then try this last question right here, 8 times 16, then we'll do it together. Okay, so we have 8 times 16. We're going to do 8 times 6 first. Okay, 8 times 6 we did already in a previous problem. We know the answer is 48. Then we have this 1 in the tens place, which means 10. 10 times 8 in the ones place is 80. So you add these results together and you get 8 and 0 is 8, and 8 and 4 makes 12. There's 1 that carries over to the ones place, and that comes down here to 128. Okay, so that's it for adding and subtracting and multiplying. The last thing we're going to do is we're going to do some division. Now, division is something that's just a little different because what you're trying to find out in division is you're trying to find out what you would multiply 37 by. Let's look at this first example, right? You're trying to figure out what do you multiply 37 to get 5,817, okay? And that result may be a nice clean whole number. It might be, it might be 10 or 20 or 35 or something easy like that, or it might be something that has what we call a remainder, okay? So we're gonna go over what that means and show you how to do this process of long division right now. Okay, so the process we follow for long division, right, is that we look at our number on the outside of our division sign here, and how many digits are in this number? Well, there's 2. So what I want to do is, I actually want to look at, I'm going to highlight this so that it's a little clearer. I want to look at the first 2 digits on my number on the inside, okay? And so what I'm going to ask myself is, how many times does 37 go into 58, okay? So if I did 37 one time, I would get 37. And if I did 37 2 times, well, that would be 30 and 30 and 7 and 7. So that's 60 and 14 is 74. So 74, let's write this out. So like 37 one time is 37. And 37 2 times would be 74. Well, 37 does go into 58, but 37 times 2, which is 74, doesn't go into 58. It's too big. So 37 can only go in one time. So the result here is going to be 1, all right? Now, I'm erasing this because I'm going to end up having to do multiple calculations here, so I'm just clearing that so I have some space. And now what I do is I take 1 times 37 and I put the result right here underneath 58. And then what I do is I actually subtract these, okay? 8 minus 7 is 1, and 5 minus 3 is 2, so there is 21 left from that. And then I bring down the next number. And the reason I need to bring that next number down is because 37 doesn't go into 21 at all. 37 is larger than 21, so there's nothing for me to figure out in terms of division there. So let me go ahead and erase that, what I highlighted. And I'm going to bring down, I'll use a different color for this. I'm going to bring down this 1 and place it right here. So now I have 211, all right? And what I need to do is I need to figure out how many times does 37 go into 211. So I need to do some times tables. 37 times 1 is 37. 37 times 2 we figured out was 74. I'm going to add another 37 to that, and that's going to give me, let's see, 4 and 7 is 11, so that's 81, and 30 is 111. So I'm getting close. I need to keep going. I think it's probably going to end up being like 6 or something, but we'll see. 37 times 4. Let's see, that's going to give me another, let me just add 37 to this. So 7 would give me 118, 148. Then I add 37 again to that, and I get 50, let's see, 155, 185. Add another 37. So you can see this is kind of a tedious process. Adding 7 to this would give me 192 plus 30 is 122. Oh no, I'm sorry, 222. Okay, and that's too much. 6 37s is too many because that's greater than 211. So I can only go in a maximum of 5 times. So my result goes at the top, and then I multiply 5 times 37, which is 185. Put the result here and subtract it. Okay, so I have to do some subtraction here with borrowing. So let's get rid of this. This is now a 0. This is an 11. 6 and 5 makes 11. 0 minus 8, I got to borrow. So this is now a 1. This is a 10. That's 2. And then 1 minus 1 is 0. So there's 26 remaining. Okay. 37 does not go into 26. It's too big. So I need to bring down the next column. So we'll use a different color for this. How about purple? No, I don't like purple. Let's do red. Okay. So bring down this 7's place, right? Okay. This is the last time we're going to have to do this because after this place, we're out of numbers, okay? So we already have our times table filled out for 37. And so I know that if I did 6 times, I would get 222, but I can go, let me try one more time and see what happens. So 37 times 7, that gives me, let's see, 7, 8, 9, 259. Okay, I can stop there because I know what's going to happen. What's going to happen is that if I go one larger, it's going to be way bigger than 267. So my answer is going to be 7 here. And then I do 37 times 7, which gives me 259. And I need to subtract this. Okay, so I'll switch back to my blue color. And we're going to do 7 minus 9. I got to borrow, so this is now a 5. This is a 17. That's 8. And then 5 minus 5 is 0. 2 minus 2 is 0. 0 minus 0 is 0. So I have 8 left over. So my final result here, okay, I'm going to have to erase this so I have room. Let's erase all that. Okay. My final result is going to be 157 with a remainder of 8, okay? So 37 goes into 5,817, 157 times with 8 left over. Okay, so let's go ahead and move on to the next problem. And our next problem, actually it looks like in all of these problems we've got just lots of just huge numbers that we're doing division on. So we're having to combine a lot of operations that we've done so far with new ones, okay? So let's go ahead and try this out. So this 49 has 2 places, and so I need to look at the first 2 places of my big number on the inside and figure out how many times 49 goes into 78. So like evenly, like no remainders or anything. So it goes in, I know it goes in one time, and I know that conclusively without having to really do anything. But I know I needed to access a times table from my last problem, so let's make one, right? So 49 times 1 is 49. 49 times 2 is 98, and I know that because 50 times 2 is 100, and if you take away 1 from 50 2 times, that's 100 minus 2, which is 98. So next problem, we have 49 times 3. That's going to give me 147, and so on and so on. We're probably going to need to access more of these as we go on, but it's easy to see that 49 can go into 78 one time. If it was to be done by 2, it would be 98, which is way larger than 78. So the answer would be 1 times 49, that result goes here, is 49. You need to subtract this. Now, in order to subtract this, you're going to have to borrow because this 8 is smaller than 9. So this is actually going to become 18. That's probably super hard to actually see. Maybe I can make my pen a little bit lighter. Hold on. I think I can. Yep, this becomes 18, and this is now 6 because we had to borrow. 18 minus 9, I should probably make my pen the original size again. 18 minus 9 is 9, and then 6 minus 4 is 2, so we have 29 left over. Now, 49 does not go into 29 because that is larger than 29, so we need to bring down the next place, and I will switch pen colors. I think I did orange for the next one. So bring down a 4, and now I need to find out how many times does 49 go into 294. Well, on my times table here, I got up to 147, so let's just keep going. 49 times 4 is 198. We're getting close. 49 times 5 is 250 minus 5, which is 245. And 49 times 6 is going to be 300 minus 6, which is 294. Ooh, that is lovely. So exactly 6 times 49 goes into 294. So no remainder left over there. So 49 times, yep, 294, just checking. Okay, so it goes in 6 times. Oops, my paper scrolled. So you put a 6 here, and then you take this 6, multiply it times 49, and you put the result. That result goes on this line, and that's 294, and you subtract them, and you end up with 0. Now you can't stop yet because you still have this last column here to look at, but there's really no more division that you have to do because all you have left is 6, and 49 doesn't go into 6, and there's no more places for you to pull numbers down from. So the result is just going to be 16 with a remainder of 6. And that's the end of the problem. If you did 16 times 49, okay, so when we do this, we have to pull this 6 down. There's no more places to pull any numbers down from. And we have to decide, does 49 go into 6 how many times? And it does not, so the result you need to plug in here is 0. Whoops, my drawing is not working. That would be a 0. Now there are 6 places, or 6 partials left, so this is going to be a remainder of 6. 49 times 160 is going to give you 7,840 with 6 left over. That needs to get you to 7,846. Okay. I need to make some room here, so I'm going to erase my 49 times tables. Okay, so next problem. What we're going to end up with is we have 2 digits here and 2 digits here, so we need to see how much does 92, you can't see that, my hand's in the way. How many times does 92 go into 46? And the answer there is none. It doesn't go in at all. So you need to put a 0 here. You need to multiply this, and that 0 times 92 is 0. So you're going to put the result right here, and then you pull down that result and bring down the next column. And now you need to figure out how many times does 92 go into 460. So you need to make a 92 times table. And in that 92 times table, it's going to be 92 times 1. I just want to make sure you can actually see that. You can. 92 times 1 is 92. 92 times 2, 92 times 3. Let's see, so 92 and 92 is 184. When you add 92 more to that, that's 184 plus 92 gives me 276. Plus 92 again. So 92 times 4 is 368. We're not quite there yet. 92 times 5 is exactly 460. So we got lucky because it's an exact result, okay? So it goes in 5 times, so you put a 5 in this place. You multiply 5 times 92. You plug the result in down here. Well, that's 460. So when you subtract those, you get 0. We're not done because we still have a place here. So we need to pull this 6 down to the bottom. Does 92 go into 6? No, it does not. It doesn't go in any time. So you need to put a 0 here. And then you have a remainder of 6. Okay, I want you to go ahead and pause the video. And then when you come back, you're going to be able to see, I want you to try the next 3 problems. And then I'm going to have the results posted for you so you can check your answers, okay? Okay, so here are the results of the 3 problems. So you should have gotten 91 with a remainder of 33 for the first problem, 58 remainder of 45 for the second problem, and 93 remainder of 38 for the third problem. So if you didn't get this, I would encourage you to come to the live sessions, when we have them with these questions, so we can kind of go over. You can show me the work you've done, and we can maybe figure out, where the mistake might have been made, or just clarify how to do this, okay? So we're going to move on to our next section of these notes. The next section is about solving problems with whole numbers. Another way to look at this is word problems. Word problems exist in every skill we have in mathematics because it really tests how you can translate a problem that you might have in real life into a numerical form so you can solve it. First question says, there are 235 books in a library. So close your eyes, imagine that library. That's a pretty small library. There's not a lot of books. 235 is not a lot of books for a library, but there's 235 books in that library. On Monday, 123 books are taken out. On Tuesday, 56 are brought back. And how many books are there right now? So this is actually a multi-step problem because we have to take away the 123 that are checked out, and then we have to put back 56 that were brought back to the library. So the first, what we're starting with is 235. And then we are subtracting 123 because when it says taken out, that means that they're taking the books away from the library. And then we actually have to add 56 back to that total because 56 books were brought back and checked into the library. So you can just do this using the ways that we've shown before. And the question, this is basically what a numerical version of this word problem is. And so what we do is we can do it step by step. We can do 235, take away 123 first. That would be 2, 1, and 1. So after the 123 are taken out, there's 112 left. Then the next step would be to take the 112 and add 56 back to it. 6 and 2 is 8, 5 and 1 is 6, and 1 and 0 is 1. So after the 123 are removed and 56 are put back, the library has only 168 books remaining, okay? So I just realized that you can't see this whole problem on the screen, sorry. There we go, I zoomed out a little so you can see the whole problem now. Okay, next word problem. Lana has 2 bags with 2 marbles in each bag. Marcus has 2 bags with 3 marbles in each bag. How many more marbles does Marcus have? So first we need to talk about Lana, and she has 2 bags. So that's 2 bags, and in each bag there are 2 marbles each. So how many marbles does she have all together? It would be 2 times 2, which gives me 4. Finally, we have Marcus. Marcus has 2 bags as well, but his bags, I don't know why I drew that line there, sorry, my bad. Marcus has 2 bags also, but his bags have 3 marbles in them, so 2 times 3 is 6. How many more marbles does Marcus have? So this is not an addition problem. We didn't ask how many they have altogether. All we're asking is how many more does Marcus have compared to Lana? Well, that would mean I need to take Marcus and subtract Lana, and I get 2. 6 minus 4 gives me 2. Marcus has 2 more marbles than Lana does in her bag. Okay, our next skill for this lesson is going to be number lines, and there's actually a piece of this section that we're going to come back and do after we do skill number 6. So just hang on tight for that. We'll get back to it. But for now, we're just going to discuss number lines. And so what a number line is it is a visual representation of how you count numbers. So most number lines that you see, they'll start with 0 in the middle, and then to the right, meaning in the green, I will change my pen to green so it matches. To the right of this, in this direction, all the numbers are going to be positive. And then if you go to the left of 0, all the numbers here are going to be negative numbers. They are less than 0, okay? And on this number line, in this particular one that we see on the screen here, we skip count these numbers by 1. They're in increments of 1. So 0, then 1, then 2, then 3, then 4. That is the gist of what a number line is for. It can help you with counting. So for example, if I gave you a math problem that said, what is 10 take away 7? Well, here's 10, right? I'm going to use this blue to signify this problem. Here's 10, and here's 7, and you have to go 1, 2, 3 spaces to get there. That's one way to use a number line to apply counting strategies. Now, we're going to do that in a different way here with these other questions. These are number lines, but these number lines, they don't have 0 in the middle. All I want you to do right now is I want you to plug in the notches that are missing here. So some of them are filled in. For example, on number 1, you have 17, then 23, then 29. What's the difference here between 17 and 23? It's 6. 23 minus 17 gives you 6. And I know that because I have to borrow from here. This becomes a 13. 7 plus 6 gives me 13. And 1 minus 1 is 0. So there is a difference of 6 here. There's 6 spaces in between 17 and 23. Is there a difference of 6 between 23 and 29? 23 plus 6 does give me 29. Okay, so we already can identify the common difference. It's 6. There's a difference of 6 between everything that we go, which means we're skip counting by 6. I want you to fill in this slot, this slot, this slot, and this slot. And I'll give you a moment if you pause the video to figure that out. Okay, we're back. So 29 plus 6 gives me 35. And then 35 plus 6 gives me a 41. and then 41 and 6 is 47. Finally, I have 53 already, so I just need to add 6 to that, and I get 59. And now my number line is complete. All the things that were missing are complete. Okay, in question 2, it looks like we have to go to one of the future slots here, like 36 and 45. There's going to be a difference here of something. How do I get from 36 to 45? Well, let's subtract them. So 45 minus 36 gives me what? Well, 5 minus 6 can't do it, so I got to borrow. This is going to be 3, and this is going to become 15. 15 minus 6 is 9. 3 minus 3 is 0. Therefore, the difference there is 9. I should use a different color for this problem, I think, shouldn't I? How about orange? So the difference here is 9. And then what about between 81 and 90? 81 and 90, the difference again is 9, because 90 minus 81, well, can't do this, got to borrow. So this is going to be 8, and this will become 10. 10 minus 1 is 9. 8 minus 8 is 0. The difference is 9. So it looks like my common difference here is 9, which means I'm counting by 9s, which means if you actually scroll back up to a previous spot in our notes, we already have a 9 times table, which means we already know that this is plus 9, plus 9, plus 9. We have all the numbers we already need to fill in on this paper. So I'm all about working smarter, not harder. So 9 and 9 gives me 18, 27. This is going to be a 54, 63, 72, 81, 90. So they're filled in. I want you to apply these strategies to the next 2 problems. I want you to do 3 and 4. Try them out on your own, and then in just a moment, if you pause this video and unpause it, we will go over the answers together. Okay, so for these next 2, this is the answers that you should have gotten. Number 3, the difference was 6 every time, and then number 4, the difference was 9 every time. Okay, so we're going to roll down here to the next section, which is about number and shape patterns. And so I said earlier that I wanted to go. Okay, so these are the answers you should have gotten for 3 and 4. The number 3, the common difference here was 6, so they were going by 6s every time, skip counting by 6. And the second one, the common difference was 9, we're skip counting by 9 each time. Okay, so let's roll down. We're on our next section here. The next section is number and shape patterns, and I said I was going to kind of like do this and then go backwards and do like number 5. It's fine. All I really wanted you to see in the difference was not the difference. The similarities of what I wanted you to see was that there are patterns that you're following. For example, the pattern here is that the difference is 9 every time. They want us to cover about shape patterns, and so to do this in sort of like a fun way, I just have 2 quick examples, and then I have one of these fun emoji solver type things. We're going to step through that problem together. It looks like my pattern here is red square, blue circle, red square, blue circle. So there should be a red square. And to even make this better, I'm actually going to just use the red color and draw a square and color it in. And that would be my missing shape. And then on the next problem, it looks like it's circle, diamond, diamond, circle, diamond, diamond. So then this should be circle, and this one should be a green diamond. So I'm going to switch over to my green color, and I'm going to draw a diamond and color it in. And that's our pattern. It's just about being able to recognize the pattern. That's all that they're trying to point out here. So our next thing is to do this lovely solve emoji. I love these. You can pull up as many as you want. If you go to Google and search for solve emoji or emoji solve or something like that. Oh, here it is. I wrote it too far up. If you go to this website right here, they have tons of these puzzles, and you can sort of like, just step through them and challenge yourself that way. You probably see them like on your social media and stuff all the time, because my friends love to post these things and try and trick people. But so it looks like we have some of this is solved already. So they told us that this building in the first slot is is 1. The value here is 1. And then this sort of like pagoda-looking type building is something else. And these two things added together are supposed to add up to 9. So the question is, what does this pagoda represent in terms of a number? 1 plus what gives you 9? And so the answer to that would be 8. So one of these little pagoda things is 8. And then we also need to kind of figure out what the factory is worth. What's the numerical value of the factory, and the numerical value of what I can only guess is like some kind of hospital or office building or something. I can't really tell, but this building with the little red sign on the top. So if we go across, 1 plus this building should give me 7, and so the difference between 7 and 1 is 6. And so therefore, that building must be worth a value of 6. And then we also want to go down from here. 6 plus this factory thing right here is going to give me 10. And the difference there is 4 because 6 and 4 makes 10. So now I know that this building... Ooh, I just scrolled my paper way up. Sorry about that. We know this building is 6. We have one of those here. So here's one of those. We have 2 factories. Careful. Because these emoji things do this all the time. They like to double them up or something so that it looks like there's only 1 when there's actually 2 or 3. 1 factory is 8, so 2 factories put together is actually 4 and 4, which makes 8. So this section right here is worth 8. And then finally, we have these 2 pagoda buildings. We said that 1 pagoda was worth 8, so 2 of them must be worth 16 because there's 2 of them. 8 times 2 makes 16. The last step is to find out what does all of this come out to. So this is sort of like a step into something that we're gonna cover another time, which is the order of operations. But in the order of operations, they say that you're supposed to do multiplication and division first before you do any addition and subtraction. So I have a multiplication here and I have an addition. So I need to do multiplication first. 8 times 16. So let's go over on the side here. 16 times 8. Well, 6 times 8 is 48. Carry that over. And then 8 times 1 is 8 times 10, I should say, is 80. And 80 plus 4 is 84. So add these values together. 8 and 4 is 12. And then 8 and 1 is 9, so 92. So 8 times 16 should give me 92. And it doesn't because I messed something up somewhere. What did I mess up? This is a great example of how you might be approached with a math problem. You might be given a problem and told that it's wrong, and you need to sort of like backwards analyze and see where the person went wrong while they were doing that multiplication. And I know exactly where I went wrong, and so you should be able to point that out too. Cross this whole thing out. Let's do it one more time. That's going to be 16 times 8, and I know what I did wrong was I put the 4 from 48 up here. Why did I do that? I don't know. I was going too fast. I wasn't thinking, whatever. So 8 times 6 is 48. You put the whole result down here, and then to that you add 8 times 10, which is 80. 8 plus 0 is 8, 8 and 4 is 12, and 128 is the correct answer. So 8 times 16 is 128, plus we have 6. And if you add 128 plus 6, the long way that we've been doing, you get 8 and 6 makes 14, carry the 1, and then 2 and 1 is 3, and 1 and nothing is 134. So the final result is 134. Hope you enjoyed that puzzle. There's plenty more of those. Like I said, if you go to solvemoji.com or Google solve emoji, you'll pull that up. And we have one more thing to talk about in this section, which my slide is not appearing. Okay, my slide has come back. Awesome. So the last thing we're going to talk about in this section is number properties. There are 3 properties that you need to know about, and this kind of kicks up the whole theory about math a little bit into high gear. So The first thing is the commutative property, and when I teach this to my students, I like to tell them ways to sort of remember what they mean. So look for the root word inside of commutative. The root word in there is commute. And what does it mean when you tell somebody that they're like commuting to and from work? You already do it. You do it every time you go to work. You're commuting. You're moving from point A to point B. So the key word here is commute, which is like moving around. What this means is that you can move the numbers around in an operation most of the time and get the same result. So let's say that I were to add 3 plus 7. Well, 3 plus 7 added together gives me 10. And you can also do 7 plus 3, where the 7 and 3 switched places. They just moved around. And guess what? You still get 10. That's the addition commutative property. The same thing is true for subtraction. The same thing is true for multiplication and division. And let's do an example of what a multiplication one might look like. You might have 3 times 2, which gives you 6. And then if you move 3 and 2 and switch places, you get 2 times 3. That also gives you 6. So that's why that property is true. The second thing is the associative property. In the associative property, what we're talking about things that are grouped together inside of a mathematical expression. So when I'm talking about grouping, I'm talking about grouping symbols like parentheses. Okay, so these are parentheses. And they are grouping symbols. They group things together so that you do them in a particular order in a problem. And so let's say, for example, that let's just do an addition one for this. Let's say I have 1 plus 2 in parentheses plus 3. And so what's the result of this? Well, in order for you to do this, you have to know a little bit about the order of operations. And so I'm going to roll down to the bottom of my page here and just give you a really quick idea of order of operations. There's an acronym that you can follow for this. The acronym for order of operations is PEMDAS. And so what PEMDAS stands for, I'll switch colors here, is, let's write it down this way, PEMDAS. What this stands for is you do parentheses and then exponents and then multiplication and then divide and then you add and then you subtract. Now really, multiplication and division, you can do them in any order together. So like you would do parentheses and exponents, then you would do multiplication, division, the order doesn't matter, and then addition, subtraction, the order doesn't matter there, because addition and subtraction are really the same thing, and multiplication and division are really the same thing. Okay, so back to our example that we were just doing. The order of operations says I have to do parentheses first. So if I'm looking at these grouping symbols right here, I see that I have 1 plus 2 in parentheses, so I'm going to do that first. That gives me 3. And then I still have this plus 3 hanging out, so 3 plus 3 is 6. Now, what if I associated the numbers differently, meaning the numbers that are friends with each other are now not friends anymore, so 1 and 2 are not friends anymore, but 2 and 3 are friends. So if I redo this problem as 1 plus 2 plus 3, now the 2 and 3 are associated, they're grouped together, and the 1 is not. But do I still get the same result? And the answer is yes, I should. So this is 1 plus, what's the parentheses? 2 plus 3 is 5. And that comes out to 6. So I ended up with the same answer. That's what associative property does. That's the magic of the associative property. Okay, so let's make a little chart here with some examples. I'm going to go ahead and use, I'm going to use letters for this, because letters are sometimes a way that we can use to talk about numbers in math, and they are variable, meaning they represent any number. So let's do some numbers here. For commutative property, meaning stuff's moving around, you can have A plus B equals C, and B plus A also equals C. They're the same. You can move the A and B around, you can flip their spaces, and you'll get the same result at the end. Now, if we were to apply the commutative property to multiplication, you can still completely do that. All you're doing is just things are moving around. So A times B is going to give you C, but B times A is also going to give you C. It's going to give you the same result, okay? Now, associative property, remember, has to do with the grouping symbols. So the first thing we're going to do is we're going to look at the associative property for addition. And what that says is that if you have A plus B in parentheses, and you add a third letter to that, which is, let's call it C, you're going to get some result. It's going to be D. All right. But if you change what's associated with itself, meaning now B and C are in parentheses, you are going to get D again. It doesn't make a difference. That's what this property is saying to you. Okay. We can also apply the same thing for multiplication and division. So if A times B in parentheses times C equals D, then we can move the parentheses around, and now A times B times C should also give me D, and that's exactly what the property is saying, is that those things, the grouping symbols can change, and you'll still end up with the same result. Okay, we have one last thing to discuss, which is called the distributive property. The key word here is distribute. You are distributing a number, and this involves grouping symbols as well. Let's see, what color haven't I used in a while? How about green? So let's say, for example, the distributive property, if I use letters to explain this, what it means is that if you have a number and it's being multiplied by something in a grouping symbol, like B plus D, okay? Now this is different from the ones we've seen at the top here, because now we have a mixture of multiplication and division and parentheses. So what you're doing is you're distributing, meaning you're taking the thing on the outside and you distribute to this first term and you distribute to the second term. That's what distributive property is. And so what you end up with is you end up with A times B plus A times D, because you had a plus symbol in here. So you need to multiply A times B, that's here, A times B, and this addition remains, and then you do A times D, that's A times D right here. So let's do this with an example with some numbers. So let's say, for example, that I have 2, and in parentheses I have 3 plus 4. So what I do is multiply 3 times 2 first, 2 times 3 rather, and you get 2 times 3. And then there's a plus sign in there. Whoops, sorry. There's a plus sign in here because there's a plus sign right here. 2 times 4 is 8. In other words, this 2 applies to both things inside the parentheses. That's what this means. This 2 being multiplied means you multiply it by everything in the parentheses. So let's simplify this. This is 6, and 2 times 4 is 8. So this is 6 plus 8, and 8 plus 6 is 14, and that is our final answer. Okay, so that's everything that we have about Lesson 2, whole number operations. You should now have all the tools that you need to go ahead and log into Essential Ed and complete some study time and move on from this section in Essential Ed. Okay, guys, until I see you next time, bye-bye.